My friends and followers, I want to speak today about the typology of gasification. My name is Flavio, and I'm the CEO and CTO of Relab and Recupera, the gasification company. And let me divide here my screen with you. And so I would ask you to refer to my other videos where I speak more generally about recycling of plastics. Today, I really want to talk to you about gasification because these questions now come to me from time to time. People ask me, why do you choose gasification? There are so different technologies around. Why you specifically chose that one? So let me explain that one. The first thing that I would like you to note is that gasification has only one product. It's a single product, and that product is syngas. And syngas is a mixture of gases. There are two gases there, carbon monoxide and hydrogen. Why syngas is important? From syngas, you can, through different technology, using different catalysts, achieve all of the chemistry. The most simple one is the conversion of syngas directed to methanol. And for methanol, you can convert to olefins. And olefins are the moieties, the units of plastics. So if I want to do plastics to plastics, here is the most straightforward route. There is nothing that is more direct than that, and also more amenable for the process management and control and quality control. So it's easier to clean a substance in the gas phase than it would be in liquid phase. And that is the reason I decided not to go over the pyrolysis. I really tried pyrolysis, but pyrolysis has some problems in the purification. And of course, when you go over gas phase, you make it easier for you. The problem of the gas phase, the traditional gasification, is the higher temperature. But that is what we work with from the beginning. So syngas is a commodity that the chemical industry uses today for producing the whole of chemistry, including the moiets for new plastics. But of course, by easy separation of the gas, you obtain hydrogen, and everybody's looking for hydrogen. So this is a way of producing hydrogen from waste. And for hydrogen, of course, you can produce ammonia. From ammonia, you can produce urea, and then you have fertilizers. So this is the route for fertilizers. Here is a very common. That's the reason syngas was developed by the Germans during the war, the route for producing diesel, because during the war, the English controlled the oil in the Middle East, so the German has to find a way for their war machinery. And they did that by developing this technology that converts syngas to diesel and gasoline. After the war, because this route is more complex to do, this was most abandoned, except for South Africa. So South Africa, all the oils and all the fuels they're producing come from syngas. So this is a technology that has been used all of the years. It was developed around the 30s in Germany. But the technology that produces the syngas is much older, and that is gasification. So let's now speak a little bit about the typology of gasification. As a technology, gasification has been around for 200 years. And the first gasifiers, they were constructed in England for the production of street gas, which was called street gas for illuminations. And that gas did not have any kind of high quality. In fact, it's so. If you want a gas as a fuel of burning, as a thermal gas, you don't need to worry about purifications and the quality of the gas, because all of the gas will burn very well. You may, of course, have to some preoccupation with the legislation. If you are in California, you need to produce some more clean gas than in other places, because the law requires you. But there is technically No, there is no technical requirement of purification. For burning the gas, it's very easy. Any very dirty gas will burn. I just want to recall that during the war also, there were those gasifiers that you could carry with your car and produce something that they call gasogen or whatever, different names in different countries, but that was the product of the direct distillation of wood. You would distill the wood, that is one of the name of gasification, is a dry distillation. You would distill and then inject the gas into the motor directly. No purification, no nothing. And the most surprise, it works. So the car, at least the car from 1939, with various, they did accept that dirty gas as fuel, and you could drive off king. So this was a technology already used during the war. I would not suggest you to use the same technology for the cars of today because they have a very different demand from purification. But I want to tell you, gasification can be very dirty and can be high pure. Now, let's look at the different types of gasifier. In these 200 years, there are many dozens of gasifiers out there, or types of gasifiers out there. And each one has been built to perform a certain process, to deliver a certain product from a certain type of feedstock. And they are different. So they are not exactly. Let's go very quickly. You have so-called fixed bed gasifier. And there are two types of fixed bed gasifier, the updraft and the downdraft. The downdraft gasifier is especially useful for biomass, for the gasification of biomass. And but this here, both the updraft and the downdraft, works very well with gasification of biomass for different purposes. Then you have this fluidized bed gasifier. These are different components of the gasifier. The advantage of the fluidized bed, especially that one, circular fluidized bed, is that the material will be running in the gasification in a circular fashion until it is completely gasified. By doing so, you ensure a more complete gasification. There is another type of gasifier, very common, and people like to cite that. This is plasma gasification. There is a difference here. When we speak about gasification, I'm speaking, at least in those gasifier here, I'm talking about a chemical reactions. That is the reaction of the oxidant, usually is air, with the carbonaceous material, the carbon-containing material, producing CO and hydrogen. This is the chemical reactions that we call gasification. Plasma is different. Plasma is the physical transfer of phase. You have materials in the solid, in the liquid phase. They will be transferred to the gas phase, and not each one gas phase. It will be a plasma because the electrons will be delocalized everywhere, and there will be no single atoms here. The temperature is like the sun. It's so hot as the surface of the sun, and of course, this very high temperature produce this plasma. When the plasma cools, then the atoms will be formed again. The electrons come to the atoms and they will react. So in the cooling process, syngas is formed. And this is a syngas of highest quality. The problem of plasma is that to sustain the plasma, you need so high temperature that make most of the process uneconomical. I have not seen proof of any plasma reactor that can be run economically feasible. I have not seen. I know that people tell me that in certain scale, in certain case, it will be feasible. I have not seen that. So it remains to be seen. I know that many companies that tried the plasma, they have abandoned plasma because it was not economically. So this has happened many times. When you talk about gasification and people believe it, you are talking about plasma, they immediately reject it. They tell me, oh no, that's high temperature, high pressure. We know it doesn't work economically. This is a special case of gasification. Do not believe that this is the common case for all the gasifier. All of these gasifier here, they work at much lower temperature, around 2000 degrees. Here is 4500 up. Now, and here is already 2000, which is quite high, but not at all so high. But I must tell you, the gasifications that we have developed at Recupera and Relapse use this technology is low temperature. By low temperature, we say below 450 degrees. At this temperature, the game is changed. The game is changed because the allothermal, here is an allothermal process that you have to inject heat from the outside, becomes an autothermal. So the heat content of the material is sufficient to drive the reactions. We do not need external heat input outside to start the process. Of course, there are some pre-process that needs energy, but the gasification does not need energy. So gasification has very important parameters that need to be controlled. The most important parameters to control to attain a high quality gasification is the mass flow rate of steam, because we gasify the oxidant is steam. So this is a steam cracker. So the gasification with the steam, we need to control that. The gasification agent, because it is steam and oxygen. So the mass flow rate of oxygen, the gasification oxidant, you need to have a perfect control, and the type of feedstock. It is quite different if you are gasifying biomass or gasifying plastics. No, it's totally different chemistry there. The reactions will be different. Now, oh, this is in Portuguese, but never mind. I just said that the product of gasification is syngas, and there is here an equivalent ratio is the amount of oxidant you are adding, and we try to keep it between 0.25 and 0.5. The conversion temperature, as I said, is around 1200 and up, but in our case is below 450 compared to plasma, which is above 3,500 degrees. So this is just that you know. Now, the different types of gasifications equipment will lead to different quality of the gas. And that is always, before you choose the gasification, you must know what you want to obtain as a product. If you are working for fuel production, as I said, you don't need to think very much about purification. No, you will have any kind of gasification will do. Let me just tell here, to produce your gas, no characteristic for FT. This is when you want to do chemistry. Here, the quality of the gas need to be the highest possible. You need to decrease the amount of contaminants, and you can do that by controlling the gasification parameter, but also adding a downstream purification process that will then purify your gas to 99.999 if you so wish. If you so wish, you will have extremely pure syngas, and that is what you need to be able to do the chemistry. So this is a very short video, and I hope I have been able to explain to you the difference between the gasification process. And I thank you very much for listening to me today.